If you test SIEM correlation rules with one log line, you are not testing correlation. Picture this. A rule is supposed to alert when a user has repeated failed logons, then a successful remote access login, then a sensitive admin action within 15 minutes. The unit test sends one failed logon. It passes. The rule ships. 2 weeks later, the real sequence happens, and nothing fires because the join state resets too early. That rule was not tested. SIEM correlation rule testing is the practice of proving that a detection rule works when several related events happen in a specific order, within a defined time window. In plain English, you feed the SIEM a small story, not a single sentence, and you check that the right alert appears. This supports the detect function you see in common security frameworks. Collect events, analyze them, and identify suspicious activity. A single event rule looks at one record. A correlation rule remembers state across records. That means the test must include the records, the order, the timestamps, and the expected result. Without that, the rule is just a written idea. Before proper sequence tests, many SOC teams rely on spot checks. They paste one sample event into a rule tester. They confirm the field names parse. They confirm a basic condition matches. That helps, but it does not prove the correlation. Rules that join identity logs, endpoint logs, network logs, and cloud audit logs can fail in quiet ways. A timestamp field changes. A grouping key moves from username to user ID. The rule still looks valid, but the chain no longer connects. Analysts then find out during an incident review, not during code review. Multi-event tests move that failure to the pull request, where it is cheaper and safer to fix. Here is the basic pattern. Start with one correlation rule. Write down the sequence it expects in Defender language. Event A, then Event B, then Event C, grouped by the same user or host inside the join window. Turn that into a fixture, 3 or more realistic log records with timestamps and expected fields. Run the fixture through the same parsing and rule path used by production, as close as your environment allows. Assert the alert name, severity, entities, and evidence. Then test the time edges. Put the final event just inside the window and expect an alert. Put it just outside and expect no alert. Also test wrong order and wrong entity. That proves state tracking, not just matching. A SOC has a rule for suspicious remote access, followed by privileged activity. The rule expects several failed sign-ins for one account, then a successful remote access session, then a privileged configuration change on a managed system within 15 minutes. The team builds a fixture with anonymized records from 3 log sources: identity, remote access, and admin audit. They set the first failure at 10 o'clock, the remote access success at 10:06, and the admin change at 10:14. The test expects one alert tied to the same user. Then they clone the fixture and move the admin change to 10:16. That one must not alert. A later parser change breaks the user field. The strength is confidence. Sequence tests prove that a correlation rule can follow the story it claims to detect. They catch field drift, parser drift, time math errors, and broken grouping keys. They also make tuning safer because you can change one condition and see which known scenarios still alert. But they do not prove every real incident will be detected. They do not replace threat modeling, log quality checks, analyst review, or production monitoring. Fixtures can be too clean. They can miss noisy data, delayed delivery, duplicate events, and missing fields. A correlation rule with no sequence test is still an unproven hypothesis. A tested rule is better, not magic. This fits inside detection engineering. The SIEM collects and normalizes events, then applies rule logic. Correlation tests validate that the logic still works when rules, parsers, and schemas change. They sit next to parser tests, enrichment tests, and alert quality reviews. UEBA can add behavior baselines, such as unusual access time or peer group deviation. But correlation rules still need explicit sequence tests when they depend on ordered events. Your ticketing and case management tools come after the alert. They do not prove the alert should have existed. CI sits before production. It blocks bad detection changes before analysts have to live with them. Start small. Pick one active correlation rule that matters to your SOC. Choose one with a clear sequence and a defined time window. Write the rule story in one paragraph. List the required fields: user, host, source, action, timestamp, and any grouping key. Build a positive fixture that should alert. Build a negative fixture just outside the window. Build another negative fixture with the same events tied to different users or hosts. Store these in a shared fixture library, not inside one rule folder where nobody reuses them. Over time, cover the whole rule set with shared multi-step attack sequence fixtures. Then run the full fixture suite in CI on every pull request. Recap in 3 beats. First, single event tests do not cover SIEM correlation rules that join multiple events. They check one record, not state. Second, correlation rules need ordered event sequences as fixtures, including the time window edges. Just inside should alert, just outside should not. Third, build one shared fixture library for the whole rule set and run the full suite in CI on every pull request. That is how you turn detection logic from hope into evidence. If this helped, subscribe. A new Security Tools Decoded episode lands daily, and this channel also publishes the daily ranked CVE brief for defenders.